Hello and welcome. Today what we're going to be discussing in this video are the properties of water and what make it such a very unique compound. So without further ado, let's go ahead and get started. I will see you, metaphorically, on the next slide. So remember, hydrogen bonds are what go ahead and hold water molecules together. So hydrogen bonds do not actually join atoms together, but rather what they do is they go ahead and attract them at a very close proximity to one another. So hydrogen bonds are nothing more than attractions between compounds. They never actually come together and connect. So here is another diagram of water and how a hydrogen bond works. So if you recall, the hydrogen portion of water has a positive charge, whereas the oxygen portion of water has more of a negative charge. So if you go ahead and have a positive with a negative, remember that opposites attract. So this will go ahead and create an attractive force that will go ahead and hold these two water molecules in relatively close proximity with each other. Now these bonds are not rigid. It's more like going ahead and attaching two tennis balls with a string. So you can still go ahead and move them around a little bit, but you can't pull them apart completely. So water has a very unique set of properties that specifically are very important for us living here on Earth. For example, water has an excellent ability to go ahead and store heat. A large input of thermal energy is required to go ahead and disrupt the organization of liquid water. So what we mean by that is it takes a lot of thermal energy or heat to actually go ahead and change water from a liquid to a gas or a solid. So what this allows it to do is go ahead and help minimize temperature changes near coastal areas. So think about a pool or the ocean. During the morning, it's going to be a little bit colder, but as it goes ahead and sits there throughout the day, it absorbs the sun's rays and the heat, going ahead and increasing the temperature. Then, at night, when things are a little bit colder outside, you'll get that real nice sea breeze that goes ahead and kind of warms the area. More or less what we're trying to get across here is the fact that, think about a coastal area like California. You don't normally see rapid and varying temperature fluctuations or changes in coastal areas. It won't be 102 one day, then drop down to 75, then increase back to 85, then drop to 60. It stays within a fairly predictable margin. Also, water has a very high heat of vaporization. At high temperatures, the hydrogen bonds will eventually go ahead and break if they absorb too much energy. At this point, the water is changed into a vapor, resulting in a cooling effect. And this is what we go ahead and call sweat. So sweat is actually your body going ahead and converting water from a liquid into a gas. So the water you go ahead and get on your skin, that sweat, uses your body's own thermal energy to go ahead and convert itself from a liquid into a gas or a vapor. So you're kind of going ahead and using your own body temperature to convert water. Pretty cool. Water can also, when the temperature drops too low, become ice, or form ice formations. So at low temperatures, hydrogen bonds will not break. But what they'll do is the bonds will get very rigid and inflexible. So what's going to happen is instead of it being kind of like two tennis balls on a string, now it's like you've gone ahead and stuck a metal rod through two tennis balls. They're still connected, but you can't really undulate or move them anymore. They're kind of stuck in the position they're in. And what you get here is a regular crystal-like structure that we call ice. And ice is actually less dense than water, so water in its solid form is less dense than water in its liquid form, meaning ice will float on water. Now ice, like we said, is less dense than water, so it'll float. Now this is very important because during the winter times, this means that bodies of water, well specifically large bodies of water, will go ahead and not freeze completely solid during the winter. If it froze completely solid, that could be some seriously bad news and potentially kill off all living things inside the water if they couldn't go ahead and adapt. So as you can see here with the ice cover actually acts as a set of insulation for the water below it. So this means that the water underneath is going to stay at a relatively stable temperature. It's still going to be very cold, but it will not be freezing, meaning that creatures like fish can go ahead and survive. So water also has a another set of unique properties, specifically two that we're going to talk about here real quick. We're going to talk about cohesion. So cohesion is water's ability to go ahead and attract itself or bond to itself. So cohesion is the attraction of water molecules to other water molecules. An example of this is surface tension. So I'm sure you've all felt surface tension at some point. Imagine going ahead and doing a belly flop into a pool. So when you go ahead and hit the water, it hurts. Because for that brief moment when you came in contact with the water, it was almost like a solid. That is what we call surface tension. Now we also have adhesion. Now adhesion is the opposite. Adhesion is water's ability to go ahead and bond and attach itself to other polar molecules. And if you remember polar, think opposite. So polar, we have a positive side and a negative side. And considering that water is also a polar molecule, this is great because that means it can easily go ahead and bond to it. So think about like water's ability to go ahead and attach itself to things like spider webs or dew on the grass. Also, there's a perfect example of surface tension. The water strider is actually light enough that it does not disrupt or break through the surface tension of the water, meaning that it can actually go ahead and float. Kind of like walking on water. Surface tension. So cohesion, water to water, makes the surface of the water like a solid film. As we said, allowing for things like water striders to go ahead and be upon it. Now adhesion, so cohesion and adhesion working together allows for something called transpiration. And that is the movement of water up a plant via capillary action because of the pull from evaporation through the leaves. So as you can see here, water evaporates through the leaves of the tree. Now when this happens, water is being pulled out, and there's water inside the tree. So as water is being pulled out, it's actually going ahead and sucking up water through the roots like a gigantic straw. So it can go ahead and replace the water that is lost. As we go ahead and reach the final parts of this video, we're going to go ahead and talk about one final thing with water. And that's the fact that water is an excellent solvent. We're also going to be discussing the acts of hydrophobic and hydrophilic substances. So hydrophilic means water-loving. These substances are polar, meaning they can go ahead and bond with water relatively easily. A great example of this is sugar. So this means that the two will mix very well. If you go ahead and take a spoonful of salt or sugar and mix it into a glass of water, over time it will actually dissolve. But you can tell that the sugar is still there because you can taste it, or you can also taste the salt if you decide to go that route. The next type is called hydrophobic. Hydrophobic are water-fearing substances. These are non-polar, meaning they do not bond with water. So they're actually repelled. A great example of this is oil. If you go ahead and put oil, any type of oil, like olive oil, corn oil, and you put that on top of water, you can go ahead and mix that as much as you like, but the two will never go ahead and bond. The final thing we're going to discuss today is a solution. Now a solution is made of two parts. We have the solute, which is the particles that are being dissolved, and the solvent, or what is causing the dissolving to occur. And the two of these mixed together is what we go ahead and call a solution. It's a homogeneous mixture made from solute and solvent, meaning that it's a great combination between the two, meaning we can't go back and get the solute out without going through a chemical reaction or physical reaction. Now there are two types of solutions. We have concentrated, where there's more solute than solvent, and we have diluted, where there's more solvent than solute. The best way I can describe this is Kool-Aid. So think about this. The solute is the powder. The solvent is the water. When you go ahead and you mix these together, you get your Kool-Aid. Now, there's two different types of Kool-Aid. If you go ahead and add a lot more powder, that is what we call concentrated. So it's going to taste a lot more sweet. Now, if it's diluted, that means that there's going to be more water than powder. It's not going to be a good ratio, so your Kool-Aid's going to taste more watered down. So to summarize this, a solution is a solute plus a solvent. And that's going to go ahead and close up shop for today on the properties of water. Thank you very much for your time today. If you have any questions, feel free to go ahead and contact your instructor. They'll point you in the right direction. And until next time, you go ahead and take care now.